Okay, number 2 says a student added 30 milliliters of a substance to 200 milliliters of water in a beaker. He stirred for 30 seconds and observed that the substance seemed to disappear in the water. Then he added 20 milliliters of a different substance. He stirred again, but the substance settled at the bottom of the beaker when he stopped stirring. Which answer choice could represent the two substances he used? So as I read, I'm going to draw some pictures. So a student added 30 milliliters of a substance to 20 milliliters of water in a beaker. So I'm going to do my beaker. This is our first substance. So he had water. And let's see what happens. So we have water. He stirred 30 seconds and observed that the substance seemed to disappear in the water. So it disappeared. So we have substance 1, and it disappeared. If it disappeared, what could we say? What could we say, Alan? If that substance disappeared, what do we know about that substance?
It didn't disappear. It went in the water molecule.
Okay, but do we see it in there?
No.
Nope. So what do we say? If it disappeared, it spread evenly amongst the water. So what do we call that substance?
Soluble.
It's soluble. Excellent. So we know that's soluble. Okay, so now then he added 20 milliliters of a different substance. So we have our second substance. So this is going to have substance 1 and 2. So in here we have water and we have a soluble substance so far. He added another substance. He stirred again, but the substance settled at the bottom of the beaker when he stopped stirring. So down here, this would be our substance 2. Which answer choice could represent the two substances he used? If this one settled at the bottom, Bryce, what do we know about substance 2? What could we say?
Substance 2 would...
We know substance 1 is soluble because we no longer saw it. It dissolved. What do we know about substance 2? It settled down here at the bottom of the beaker. What do we know?
It's more dense than water.
It's more dense. Excellent. It's more dense. And what else do we know if they stirred and it settled at the bottom? What do we know, Ryan? If they stirred and it settled at the bottom, what do we know about substance 2? We know substance 1 is soluble because it disappeared. What do we know about substance 2 besides it's more dense, which I would agree?
I don't know.
Casey, what do you think?
It's not soluble.
It's non-soluble. Excellent. So we're looking for a soluble substance and a non-soluble substance. Ran out of space there. So let's see what we have. So A is salt and sugar. Remember, we're looking for a, let me make that so we can read it. We're looking for a soluble and a non-soluble. A. What about the salt and sugar, Lena? We're looking for a soluble and non-soluble. What do you think about A? Could that be our answer?
No, but the first one is right. The second one, it shouldn't be soluble.
Okay, so we have two soluble substances. So that makes that incorrect. Awesome. Michaela, what about B? B says pepper and sand. What do you think about that, Michaela? Can that be our soluble and non-soluble substance?
Sand's non-soluble.
Okay, what about pepper?
Pepper is also non-soluble.
So those are two non-soluble. So that cannot be our answer. What about salt and sand? Cody, what do you think about C?
Could be right.
Okay, do we have a soluble? Which one's soluble?
The salt, the other one is
Salt is soluble and sand is non-soluble. So that could be our answer. Let's look at D, sugar and powdered drink mix. Liam, what do you think about sugar and powdered drink mix? Is that a soluble and a non-soluble? No, why not?
because they're more soluble.
They're both soluble, so we have two soluble. So if we look at that, the only one that has a soluble and non-soluble is that C. Excellent.